So we're going to multiply radicals now. And we have a rule. We need to remember that when I'm multiplying two numbers under the same type of radical, like root a times root b, I can actually rewrite this as one radical to become the square root of a times b. We need to keep in mind the numbers outside the radicals can talk to each other, the numbers inside the radicals can talk to each other, but unless we can simplify it, they can't talk to each other. This first example, we're going to take 2 root 3 times 5 root 6. Again, the numbers on the outside can talk to each other, so I actually am going to end up with 2 times 5, and then radical 3 times 6. And notice I can use the rule above and make it all under one radical. 2 times 5 is 10, of course. And under the radical, when I multiply it out, I get 3 times 6, which is 18. Now, just like with a fraction where we have to always reduce it, a radical, we have to always make sure that we simplify it. So this is going to become 10 times. Now, root 18 becomes 2 times 3 squared when I prime factorize it. And very nicely, the 3 squared under the radical gets to come out. So I get 10 times 3 times root 2, giving me 30 root 2. And that's as simplified as I can make that one. So let's multiply some other radicals. For example, I have the square root of 2 times 6 plus root 10. Now in this case, I'm going to use the distributive property. And I'm going to multiply root 2 times the 6. So I get 6 root 2. And I'm going to multiply the root 2 times the 10, root 10, which is going to give me root 20. Root 2 times root 10. I'm going to use the rule from above where I can actually multiply the radicals to give me root 20. Now, like the previous problem, we need to simplify our radicals. Root 2 does not simplify any further, so 6 root 2 is going to be the same. However, root 20 becomes the square root of 2 times 2 squared times 5, pardon me. So the 2 gets to come out. Now, these are not like terms. I have root 2 and root 5, so I'm unable to combine these up. So this actually is my final answer. 6 root 2 plus 2 root 5. Next up, we're going to have root 3 minus root 5 times root 2 plus 7. Now here I have to use FOIL. So I'm going to start out by multiplying root 3 times root 2, which gives me root 6. The outer terms are going to give me plus 7 root 3. 7's on the outside, root 3 is still on the inside. The inner terms, I'm going to apply the rule again, so I'm going to subtract root 5 times root 2 is root 10, minus 7 root 5. Again, the 7's on the outside, the root 5 is on the inside. Now, if I can combine up any like terms, I would need to try. I cannot in this case. And I can't simplify. Even though 6 breaks down into 2 times 3, there's no perfect squares. Same with 10. 10 is just 2 times 5, but I don't have anything squared there. So this is my final answer. I can't go any further here. Next up, we're going to have 3 root z minus 4 times 2 root z plus 3. Again, I'm going to apply FOIL. This is going to give me 3 times 2, which is 6, times the square root of z squared These are my first terms. My outer terms are going to give me 9 root z plus 9 root z, because 3 and the 3 are both on the outside, so they can talk to each other. Minus, the inner terms are going to give me negative 4 times 2, which is negative 8, times root z. And lastly, negative 4 times 3 is minus 12. Now I need to try to simplify 6 times z, root z times root z just gives me z. You can rewrite it with z squared under the radical, it's fine. It all becomes just z. The inner terms, the inner and outer terms actually combine up. I have 9 root z minus 8 root z. Because they're like terms, I can actually subtract the coefficients. 9 minus 8 is just going to be a plus 1 root z, or just root z. Minus 12. I can't simplify the radicals anymore, and there are no more terms to combine up. Z and root z are not like terms, so that is going to be my final answer. Next up, let's try a perfect square. We're going to have root 3 minus 7, all squared. Now we need to remember that I can't just give a square to both. It's tempting, but we can't. We need to rewrite this, actually, as root 3 minus 7 times root 3 minus 7. Now I'm going to FOIL. Root 3 times root 3 is root 9. The outer terms are going to give me minus 7 root 3. The inner terms are also going to give me 7 root 3. And negative 7 times negative 7 is plus 49. Root 9 just becomes 3. Negative 7 root 3 minus 7 root 3 is going to give me minus 14 root 3 plus 49. And now I'm going to combine it by like terms, which is going to be the 3 plus the 49 to give me 52 minus 14 root 3. Now, it's very tempting to see that 52 and that minus 14 and try to subtract them. We can't do that. They're not like terms. There's no root 3 with the 52. So that is our final answer, 52 minus 14 root 3. We can go no further. Next example. I'm going to have root 5 plus 2 times root 5 minus 2. Now, when I have the plus and the minus like this, when they're the same, we actually have a special name for them. We call these conjugates. That will be important when we want to divide radicals. So we're going to go ahead and multiply this out. The first term is going to give me root 5 times root 5, which is root 25. You can just put 5 if you see it. Outer terms give me minus 2 root 5. Inner terms give me plus 2 root 5. And 2 times negative 2 is minus 4. I'm going to notice in this case that the inner and the outer terms actually are going to cancel out. Root 25 is just 5. Inner and outer terms, they are gone. They have canceled out completely. Minus 4. And we end up with, just very nicely, a 1. Now, I want you to compare this one to the perfect square right next to it. They are different. They are not the same. Make sure that you understand the difference between the two. The nice thing about multiplying conjugates is it gets rid of all of the radicals. Notice when I multiply these two conjugates together, we just got the number 1. So if we ever need to get rid of a radical, we can multiply it by its conjugate.